Uh, we'll continue with our next presentation, and that is from Professor Brito Cruz. Professor Cruz is the Senior Vice President, Research Networks at Elsevier and an Emeritus Professor of the Physics Institute, Unicamp in Brazil. From 2005 to 2020, he was the Science Director of the Sao Paulo Research Foundation in Brazil, and in 2019 he was co-chair of the Global Research Council. Also, most noticeably, and recently he was appointed by the UN as a member of the 10-member group for the Technology Facilitation Mechanism of the Sustainable Development Goals. Professor Cruz, welcome, and we look forward to your presentation.
Thank you very much, Walter. Can you hear me? Can you see me?
Yes, we can see you and hear you very clearly.
Oh, thank you very much. It's a great pleasure to participate in the 16th Stellenbosch University Library Symposium. And I will be presenting some thoughts and some data about trends in artificial intelligence research assessed via bibliometric analysis. I will share my screen so that you can see my slides. So please let me know if you, oh, they are there. Yeah. Okay, so the summary of my presentation is that I would like to make a very brief introduction about the niceties and the interesting things in bibliographic searches by commenting on some early papers on artificial intelligence. Then I will show you how I did the search and obtained the data I'm going to show using Elsevier's Scopus database, and then comment on some of the characteristics of the set of publications in artificial intelligence today, trying to focus some aspects related to South Africa, and then a short conclusion. So, as you probably know, bibliographic search is educative and it's also fun. I remember in a very nostalgic way when we could go into the library and open a volume in one of the shelves and then see a reference that would send us to another shelf and then another reference, and then you could spend uncountable hours of fun and of learning, going from shelf to shelf, finding interesting things to read and to study. So that's kind of what happened to me in preparing for this talk. I started this bibliographic search about artificial intelligence, and I couldn't stay with the search. I veered away several times to read some of the papers because their titles were too enticing. So one example is this one here, which is an article from 1960, where Martin Schubeck from the General Electric Company wrote about a bibliography on simulation, gaming, artificial intelligence, and allied topics. That's a very useful and very intelligent article that lists the bibliography which existed already in 1960 on topics related to artificial intelligence. And reading this bibliography, I found this very interesting paper on the journal and the American Journal of Psychology. Title is Mind and Mechanism, Professor Edwin Boring, Harvard University. And he starts with a question which I found interesting. What properties would a potato have in order to be conscious, which relates to the discussion we just heard about the robots and the humans, and the robots, would they think about forgiveness? Would they think about guilt? And those are topics which were discussed in this article from 1946. So you see, humankind has been thinking about those problems for a long, long time. And then I found this other quite interesting paper, which is one of the first ones that deals with computers and intelligence, which deals with pattern recognition and modern computers. You will see here in the first 4 or 5 lines that the author defines pattern recognition as the extraction of significant features of data from a background of irrelevant detail. And he goes further to say, we are interested in simulating this process on digital computers. So they were starting to learn and discover, and this is a reference I found in this chapter by Mendon Plasek, recently published in 2021, in this book, which has this very nice and interesting title, The Cultural Life of Machine Learning. So that led me to this last reference that I want to mention to you, which is an article from 1958 about a learning machine, R.M. Friedberg from IBM. And then in the abstract, he points out that machines would be more useful if they could learn to perform tasks for which they were not given precise methods. That is, I found that so beautiful and so interesting, especially coming in 1958, and especially because, well, you all know this joke about computers, that what makes us hate them is that they do exactly what we tell them to do, not what we want them to do. So it would be so nice if we could have computers that would learn to do what we want them to do. They would discover from our feelings or from the way we send the commands what they are supposed to do to make us happy. So those are some of those references which I found in this interesting process of studying the bibliography for this presentation. And then I will mention to you that I did this search using Scopus, which is a giant file of index cards of publications. As you know, presently Scopus has 84 million items covering 7,000 publishers across the globe. And Scopus covers scientific articles in the fields of physical sciences, health sciences, social sciences, and the life science. So it's a very complete bibliography that goes back to the beginning of the 20th century. So it's a fun thing to work with and something from which we can learn a lot. And bibliometric searches are complex and they can always be improved. Elsevier has done a few years ago, using artificial intelligence, a very specific and complex search to understand the scientific production about artificial intelligence, especially covering China, Europe, and the United States, which came out in this report, Artificial Intelligence, How Knowledge is Created, Transferred, and Used. They did this very nicely, minimizing false positive with details on topics and impacts, how topics connect to each other. For this talk today, I chose to use a simplified approach because that is an approach that each one of you, if you are interested, you can go home to your computer and do the same search and refine it to exclude the false positives and perfect it to look for all the publications which interest in the topics that you want to learn about. So what I did is I built a search string with 118 terms, which is shown here. Things like adaptive learning, artificial intelligence, associative learning, automated pattern recognition, unsupervised machine learning, 118 terms which I use it in Scopus to search for the papers which mention, either in the title, in the abstract, or in the keywords, any one of those 118 terms. And I ended up finding more than 2 million publications published after 1960, which deal with at least one of those terms. And out of those 2,688,000 publications after 1960, 2.4 million came after 2000. So about 80% of them are more recent. And the countries that are more present in this list are, as I show in this figure, China, the United States, and then there is a big difference here. And then we have India, the UK, Germany, and several others that work in topics related to artificial intelligence. Many times, the articles are not about artificial intelligence. They might be about using artificial intelligence techniques in order to study other domains of science, like, for example, particle physics or medicine or agriculture and so on. So there is a sizable number of publications in the world today dealing with topics related to artificial intelligence. And if you look at the evolution, at the time evolution of this number of papers across the years, I believe we can find some interesting features there. First one is that for the world, you will see that this curve here looks more or less like having an exponential growth, which it does. If you plot that in a log scale, you will find that it's close to a straight line, especially in the last 5 or 6 years from 2015. And it grows at a rate of 16% per year, which is a very big rate to be maintained for many years. You can also see that after 2015, there was a change in the trend here. Somehow the curve was tending to have a smaller growth each year, and then it picked up and gained speed in its growth. That is for the world. If you look at the main contributors, like China, you find again this feature of this speeding up after 2015. Here in China, we have this other feature which I found interesting and deserving some more study, which is this plateau which existed from 2010 to 2016. Why is that? They had this slowing down in the publications in those topics in such a strong way right in 2010. But anyway, there is a very strong growth, China going at 23% per year. If we look at the second one, which is the United States, here there is a mistake here. That should have been 15% for the United States, as we show in the log scale. Again, there is this small, not quite a plateau, but a slowing down between 2007 and 2015, and then this picking up of speed after 2016. And we can look at the same curve for the case of South Africa. If you look at the curve for the United States or for China, you will find that China is publishing 80,000 articles per year in topics related somehow to artificial intelligence. The United States is publishing close to 50,000. South Africa is publishing around 1,400. Of course, it's much smaller in population than the United States and China. And it again shows this interesting growth, especially after 2016. The growth for the case of South Africa is plus 19% per year, which is actually higher than the growth in the United States, higher than the growth in the world average, and closer to the 23% per year that China is performing at. Those papers with authors in South Africa, what are they? What do they talk about? So I found interesting this one, which is one of the oldest ones from 1972. A researcher from Cape Town, Milner, studied pattern recognition applied to measurement of human limb positions during movement. So they had to code and program a computer to follow the position of the legs of a person during movement in order to learn about movement. Department of Bioengineering and Medical Physics. He did that together with a colleague in Canada. And for example, we can also learn about the article with authors in South Africa, which is the most cited one in artificial intelligence topics, in which Professors Vanderberg and Engelbrecht from the University of Pretoria studied particle swarm optimizer, which are algorithms based on optimization of connections of a population. In more broader terms, from 2016 to 2020, papers published with authors in South Africa about artificial intelligence talked about learning, about networks, about neural nets, about optimization, about algorithms, and as compared to the period 10 years before, 2006 to 2010, we can see that learning appears more, optimization appears in a stronger way, networks are more present. So that's an impressionistic way to look at that without reading the papers, which is what one should do, right? Read the papers. But that's a way to look at the topics they have been covering. In Brazil, there also is a growth, which again looks like an exponential curve, which for recent years is going at 14% per year since 2015. If we choose to compare the performance of some countries, and here I show 5 countries, China, Thailand, United States, Brazil, and South Africa, and the world. And the vertical axis here is showing the number of artificial intelligence related publications as a percentage of the total for that region. So you will see that for China, it is above 10%. For Thailand, it's around 8%. For the world, it's slightly below 8%. For the United States, it's getting close to 7% and growing. Brazil is kind of steadying up around 5%, and South Africa is at around, again, 5% and growing up in the participation of artificial intelligence in the total of its scientific production. One thing that we can calculate there is what we define as a relative activity index, which is a ratio of 2 shares. It's the division of the share of articles on AI in a region divided by the total of that region and then divided by the share of articles on AI in the world total divided by the world total. So it shows the relative presence of artificial intelligence in the scientific production of one region. And then we can, using this bibliographic study, learn about what happens in different fields, which fields are using more or which fields are using less artificial intelligence, and how that happens in different countries. We will see, for example, that in China, which is the red line here, material science has a presence of artificial intelligence which is 1.2 times that which happens for the world average, which is the dashed black line in the figure. And we can see that, for example, for Earth and planetary sciences, the presence of artificial intelligence topics is about 1.5 times the world average. We can also see that, again, in China, for the health professions, they are almost 3 times above the world average in terms of using artificial intelligence, and they are 2 times above the world average in neuroscience with artificial intelligence. Going to the topics related to South Africa, we would have here a display showing which universities in South Africa contribute most of the publications in artificial intelligence, which are Johannesburg, KwaZulu-Natal, Pretoria, Cape Town, and Stellenbosch, and Witwatersrand. So this is the type of data that is relevant for planning if when organizations want to organize strategies to develop the field in a region or in a country or in a university. And again, looking at South Africa, a good number of those publications have co-authors from other countries. And the main co-authorship countries, in the case of artificial intelligence topics with authors in South Africa, are the United States, United Kingdom, Australia, France, Germany, and then it goes decreasing. There's a good number of papers with co-authors in Iran, in Sweden, in Brazil, and that again is information that allows for the designing of strategies to increase collaboration, to reinforce certain topics, and advance faster in the field. In conclusion, I wanted to highlight to you that by looking at bibliometric data, we can learn that there is a strong growth in artificial intelligence publications in the world. This growth has been strongly accelerated after 2015. The year-on-year growth is around 16% for the world, 23% for China, 15% per year for the United States, 19% per year in South Africa. There is a tendency for countries in Asia to show stronger growth than the world average in this particular field. There is also a growth in the fraction of national publications which relate to artificial intelligence topics. And that, I believe, happens because more and more fields of research are using artificial intelligence, are adapting artificial intelligence and machine learning technologies and algorithms and procedures in order to advance their particular fields. So we will see that in 2020, for the world, 8% of the publications had some relation to topics in artificial intelligence, while in 2015, this percentage was only 4%. So it doubled in 5 or 6 years. In China, it changed from 6% to 11%. In the United States, from 3% to 7%, it more than doubled. In South Africa, it went from 3% to 4%. For the case of South Africa, the fields of chemical engineering, energy, dentistry, nursing, and economics and econometrics have a relative activity index higher than the world average, which means researchers in those domains are using more or relating more to artificial intelligence than the world average researcher is. And in the health professions, we see that they are using artificial intelligence less than the average researcher in the world. The main institutions are Johannesburg, KwaZulu-Natal, Pretoria, Cape Town, and Stellenbosch, and the main collaborators, the US, the UK, Australia, France, and Germany. So what I hoped to show here is that by using bibliometric searches, we can learn some of these things, and we can learn many other things like topics which are more present, the impact of the articles in the research community through citations. We can also learn about how those articles are cited, for example, in patents, or how they are cited in the media, leading us to learn about the impact of that in technology or the impact in the way society sees and learns about artificial intelligence. That's what I had to show. Thank you very much.